In this brief demonstration, we're going to show how you can build a custom web service using OpenSpirit Connect. So we'll start off with a designer project, and let's go ahead and make a new process definition. In this case, we're going to make a process definition that will implement a web service. So let's go to our process palette and drag in a process definition here, and we'll call this web service, giving it a name that tells us what it is. And let's open up that process definition, which right now just has an end and a beginning. Well, our web service needs to start with a web request. So let's go to the HTTP palette, and we'll go ahead and start this process with an HTTP receiver. This is simply activity that waits for a HTTP request on a particular port. And we have to tell it what port we want to listen to, and we're going to connect to port 777 on a given host. In this example, we want to make a web service that will allow the user to type in a fragment of a well name, and will list header attributes from all wells that match that fragment. So we want to provide an input parameter, and you can have an arbitrary number of parameters here. We'll have an input parameter of type string that we'll call name. So that's the beginning of our web service. Then what we want to do is to issue a query back to a database. In this case, we're going to query our well master, which is PPDM. It could have been any of the data stores that OpenSpirit connects to, or any of the data stores that can be connected to by a JDBC driver. So I'm going to go ahead and drag in an OpenSpirit query activity here, and that will allow me to query for the attributes I'm interested in. Then the output of that query I want to map to my company's definition of how they want to see well header attributes. So we'll include what's called a mapper activity. This is commonly used to basically change the naming of the attributes that you've read. So I'll go ahead and drag in a mapper activity, and the output of my mapper activity will be a new XML document, or XML representation of the listing of the wells. I want to bring that back to my web browser formatted as a nice HTML table. So I'm going to take advantage of the fact that I can do arbitrary XSLT transformations of the data, and I have a generic transformation already built that takes my result set XML structure and turns it into an HTML table that looks nice for display. So we'll get a XML activity here, which is to transform that XML, and then we need to formulate a response to our original request. So we have to go back to our HTTP palette, and we need to go ahead and send a response back. And those are all the activities. All we need to do now is chain them together. So we want to take the HTTP request, query for data, map it to the names we're interested in, transform it to an HTML table, and then send it back to the web browser. And that's done. So now we have identified the activities. Now let's go ahead and configure them. So we already configured the receiver activity. Again, it's going to pass on a name, a string parameter that we'll use in our query here. So let's go ahead and configure the OpenSpirit query. We'll go off and use a data connection. Looks like we already have a connection to our PPDM well master. We'll use that, and let's construct a query. And here we're going to indicate what data we're interested in. We're going to query against the OpenSpirit wellbore table, which gets mapped into PPDM. Again, we could have been querying any database here, either via OpenSpirit or not. Let's get some attributes that are commonly displayed, such as the well identifier, maybe the well name. We want to get the total depth of the wellbore, and let's join to the parent well to get some attributes from the well itself. Let's get information like the operator, the field that it's in, and let's get its surface location. So there we've now queried, constructed our query. Oh, we forgot to constrain our query. If we leave it like that, it'll return all the wells in our well master, and we don't want to do that. We want to just constrain it to be wells where the name is similar to. We can either use a like, which is a SQL like operator, or similar to, which uses a regular expression. I'll use regular expressions. I type in a question mark here indicating that I want this to be filled in at execution time. So now my OpenSpirit query activity, if you look on its input tab, it's expecting an input. It needs to know what is that name fragment that's going to use in its where clause. And we can get that very simply from the previous step in our process here, where we have a parameter, which is output, which is the name. That's what the user put into the web browser. So now we've configured this and mapped its input. Let's go on to the next activity. And this activity was going to allow us to construct a schema, or a way of representing how we want to display the well header attributes. If your company already has some standard schemas for commonly used business objects, you can simply use those. But we're going to generate this inline here, so we're going to construct on the fly the schema that we want to use. So we want to have a series of wells, so we'll make a element called well. There'll be a complex element, and we'll make it be repeating. Then for each well, we want to have a series of attributes. One attribute might be the name, so we want that column to be called name, and let's say that's optional. Then the next column might be the UWI, and let's say that that's required. And then we want perhaps the name of the operator, and that again may be optional. Let's put down the field that it's in. So we're getting to choose the names and also the optionality or not of these different attributes in what we consider to be a well in our company. So let's make field be optional, and let's put down TD, the total depth of the well, and that's not going to be a string, that's going to be a decimal type, and actually be a float. And let's get another one here, which will be the let's get the latitude, and that's going to be a decimal double. And let's go ahead and put in another one here. I'll move that, change the ordering there as I desire. Longitude, and we'll make that be a decimal. And again, that's probably optional. Not every well has location. That's probably optional, and TD may be optional as well. So in our little simple schema here, we've defined the names we want for the different attributes, what types they are, and their optionality. So now we've created that. So now if we go ahead and look at the input to this mapper, it's now defined the schema that we just created here. And we need now to map into this schema the data we read via the OpenSpirit query. We'll simply go to that OpenSpirit query activity, and we want to, for every result, we want to create a new well. And that's exactly what we're going to do here. For every result, create a new well. And it automatically matches on some of the attributes whose names are the same. And we'll go ahead and accept these matches because the well name is the well name and the field is the field. So we'll go ahead and do that. So it's pre-populated some of the mappings for us. Now, where the names didn't match, we can simply drag and drop. The identifier goes to UWI, current operator goes to operator. You notice in the OpenSpirit query, total depth was a complex element. It had both a value and a unit. And location had both an X, Y, and Z and a coordinate system. We want to just map the value part of the total depth here to report in our little web service, and similarly we'll map the X to latitude and the Y to longitude. I should point out that the data connection we made back to our well master, we asserted a desired coordinate system, so everything comes back converted to a common geographic coordinate system. It could have been a projected coordinate system. In this case we had set it to be geographic. So now we've completed that mapping. Let's save. Now we go to the next activity, which is just a simple transformation. It's just going to take the text that we have in the previous, and then we're going to use a style sheet we already have created. This is a generic style sheet to take a result set that comes back from the query, series of repeating rows, and converts it to an HTML table. So it doesn't need any other configuration, but just need to do some simple mapping. It's expecting an XML string or an XML structure converted to a string. So let's take that there. It's red indicating that it's not happy with the input. The reason being is it's expecting a string, and we gave it a XML structured document here. So we can use our simple function editor here to get a string function, which is called render XML, that takes that XML structure and renders it as a string, and we'll take off some of the default options that we could have applied there. So now it's turned black, it's happy. Now let's go to the very last activity, where you need to indicate this is response for which request. Well, the request at the beginning of this process, and then we also have to map it, tell it what data to return, what content to return to the web page. We want to take the output of that transformation, which is be a HTML table. So let's go ahead and map that in, and now we're done. And typically at this point you would deploy this to a running instance of our engine that could be elsewhere on their network, and then you just have the web service running. But we're going to run it within the design environment here in order to test it out to make sure that it does what we expect, to make sure we didn't make any errors. So let's go ahead and start this web service. And it's starting an embedded web server listening on port 777. And so let's bring up a web browser to actually interrogate that. So let's go ahead and let's see, localhost was the name of my host, 777 was the port, and I need to give it a parameter which was called name, and I can look, for example, for all wells that start with 48. And again, I chose to use the regular expression, so .* means any number of any character. So it's going to look for all wells that begin with the characters 48. I go ahead and hit return. It goes off. The first time it hits the query, it takes a little while because it has to start up, and there it came back with my my table here. You notice that it also came back with an error. It turned out that I'd issued a second. I hit the key by accident twice here, so I really need to have a handling of an error condition. So I need to handle the fact that I may not have a parameter input. It actually got two queries there. So let's add a little bit more to this simple web service. Let's add another transition where we're going to respond with nothing, just end it. So what we want to do is we want to say we only want to issue a query if we actually have a value for this name string, because it doesn't expect a null in there, or if that name's actually there. So let's click on this transition, and we want that to be success with condition, and the condition is that we want to make sure that the parameter, that name, is present. So we can use our function here. There's a set function that says exists. So I want to respond true if that parameter called name is passed from the web request. And so that means it will only go down this branch if that's supplied. Otherwise it will go this branch and just success with no matching condition, and just return without actually going through the queries because we didn't supply what was required. So now let's try running this once again. And now let's go ahead and go back to our web browser here, and we can issue that query again, and it goes through, it issues the query, and it comes back with the data. All those wells that begin with 48, or I can look at all those wells begin with the number 1. Oh, I didn't hit return the correct way. 1 dot. There we go. So now it goes off and issues a query and finds all those wells begin with the number 1. So a very simple way of constructing a web service. This was a particularly simple web service, but you can build upon this and handle, in this case we're showing REST-style web services. You also could have XML SOAP web services, or a proper set of WSDL defining the interface. The choice depends upon what your target usage is. So just another illustration of how you can use OpenSpirit Connect to expose web services, in this case interrogating a database, doing automatic coordinate transformation, and displaying the data inside the web browser.